Hi, welcome to Sam's Maths Lectures. Welcome back. It's been 2 years, a month, and 4 or 5 days, depending on when I upload this, since I last uploaded a video. Um, I've decided to come back to YouTube and start making videos again, start making more content, um, because I think I was just too busy before and didn't know as much as maybe I needed to be doing as much as I wanted to do. But I'm back now. My old content, I've taken it off YouTube for now. Might come back one day, it might not. Um, but I'm going to be putting out new content, hopefully. Um, so I am back. So I'm gonna be doing sort of what I was doing before, the sort of video lectures and so on, but also other stuff. So if you look up here, this is called Sam's Maths Adventures. So I'm gonna be doing a sort of vlog where I'll talk about what maths and physics now. What maths and physics I've been up to since the last vlog. If there's sort of a interesting thing I want to talk about, but it doesn't fit into a lecture series, or I don't want to do a full video about it, I'll sort of list it there. That sort of thing. So it's going to be sort of regular-ish touch-in session. It's probably not the word, but oh well. Where I talk about what I've been up to. So yeah, I'm bringing the channel back. What you can expect? Don't expect too much. I don't promise anything, but obviously vlogs, as I mentioned, what I'm up to, things I think are worth sharing. Video lectures. I'm gonna start doing some for physics as well, because I was a physicist before I was a mathematician, and it's good to, I think, to get both sides of that out, because I'm enjoying maths and physics a lot more than I was when I first tried out YouTube a couple of years ago. Also, maybe some reading stuff. So if I read a paper, some sort of reviews of that. If I read a book, maybe a chapter summary, a book review. Maybe I'll go through some problems, that sort of thing. I don't have anything actually that I particularly wanted to share in this first video. So I thought instead I'd sort of give a bit of background to who I am and what I've been doing. So what I've done so far. This is just kind of a list of the various things I've studied. Maybe I'll talk about what's interesting about some of them, whether I think I'll be talking about them more in future, that sort of thing. So I started studying physics at the University of Oxford in 2018. First year we sort of had quite a varied course. We had bits of physics, bits of maths. So the physics course we did classical mechanics. We did some stuff where you draw force diagrams and solve equations. We did Lagrangian mechanics, some stuff to do with that, and a bit of analytical mechanics. We did a very basic course on special relativity. It was something like 8 lectures long. It was enough to learn some special relativity, but obviously lots was missing. We did some electromagnetism, nothing too fancy, lots of sort of working up to Maxwell's equations in their vector calculus form and showing that light propagates, and that's basically where we called it. We did some optics and some circuit theory, which I didn't love, and labs, and I doubt I'll be talking about any of those at any point on this channel. But relativity, mechanics, and electromagnetism definitely might come up at some point. Then we also did a lot of maths. In first year we did linear algebra. We had a very mathematical linear algebra course that was basically as if it had been taken from a maths course instead of a physics course. We also had a very rigorous ODEs course on differential equations. Then we did some vector calculus, which was a lot less serious, and some semi-serious complex analysis, so nothing too heavy, but basically all the complex analysis tricks that you need when you do all the integrations in quantum field theory and other parts of physics. Then I took a year out of my degree after first year, and this is when I sort of really started to fall in love with maths. So I've written everything in red here because it was very much self-studied. I would not claim that I'm an expert based on this. It was sort of self-led. I was bored, there was a pandemic going on, and it was something to do. So I looked at some analysis, topology. I looked at quite a lot of group theory actually, rings and modules, functional analysis, some differential geometry, some like analytic set theory, like really looking at the bare bones of maths, which was all very interesting. I think this is sort of something that I still really enjoy. Group theory and topology in particular. They were the first things that I tried making videos about. I think when I start making lecture videos again, they'll probably start with group theory 101. But I'm 2 years older now, and I've learned 2 years more group theory. So then my second year of my degree, so mainly physics this time from the actual degree course itself. We did a second electromagnetism course. It had some optics in it, which I'm not going to talk about because I've forgotten it all, and some circuit theory, which I didn't pay attention to in the first place. But we did some electromagnetism sort of at the level of the textbook by Jackson. I think the first 7 chapters of that or something like that. So working with potentials and using sort of more advanced equations for determining fields. I can't remember off the top of my head because it's been sort of a year and a half since my last exam on that. So I can't remember the full content. Then we did a first course on quantum mechanics. We got 2 different courses. We got quantum mechanics and further quantum mechanics. It was basically just a standard undergraduate course. If you've read the book by Binney and Skinner, it was pretty much that book because James Binney, who wrote the book, used to lecture the course, and the course hasn't really changed since then. Then we also did thermodynamics and statistical mechanics. So those 3 together were like our big options. So we did some cool StatMech stuff, statistical mechanics of various things, Bose-Einstein condensates, quantum gases, that sort of thing, and then also some like standard thermodynamics, what's a heat engine, stuff which I enjoyed less. Then we also did a second course in classical mechanics. That was an optional one, and it did more on the Hamiltonian formalism, bit of Noether's theorem, Euler angles and rotations of rigid bodies, sort of to the level of Landau and Lifshitz volume 1. Basically just that book was our course. Then we had a mathematical methods course from the physics department, which was taught by a pretty hardcore string theorist wannabe mathematician. So there was some very interesting stuff there. There was sort of measure theory and topology for a little bit, sort of really rigorous what it means to integrate something, because obviously we're going to be integrating in quantum mechanics, so they wanted us to really know what integration meant. We did some functional analysis, looking at Hilbert spaces for quantum and various theorems about self-adjoint operators, and then also Fourier theory, because everything is a Fourier transform. And we did some PDEs and some ODEs as well, so sort of methods of solution we didn't cover in first year. Then I also took a course optional on topology and groups, which was taught in the maths department here at Oxford. It's really more topology intersect groups. It was a first course in algebraic topology almost. It was talking about the fundamental group of spaces, and CW complexes, how you calculate fundamental groups, what the fundamental group does, a bit on sort of functoriality and stuff like that. They didn't want to say category theory, they didn't want to say functor, but kind of teaching us what that meant. It was like there were very loose sort of comments on what a limit might be. And then in my own time, I obviously learned some category theory to go along with the topology and groups. I did some algebraic geometry, some algebraic topology, and I followed the Oxford course on homological algebra. So maybe that should be in green. I've put courses I followed but didn't take in green later on. Um, but yeah, that was pretty interesting. And I haven't written it down, but also I did some relativistic quantum mechanics. One of my tutors gave us sort of, I think it was something like 5 or 6 hours of just going through relativistic quantum, which was really fun. He even taught us some basic ideas of field theory, not quantizing it, but relativistic quantum mechanics and classical field theory, and then a little bit of looking at gauge theories within classical field theory, which was really fun. Then third year, I did 5 major papers in physics. So special relativity, it was building on what we'd done in first year. It was sort of a good second course in special relativity. Also covered lots of sort of radiation, covariant forms of Maxwell's equations, and so on. We did a course on atomic and laser physics, which was sort of about 10 lectures on atomic structure, basically just heavily applied quantum mechanics, and then another 10 or so lectures on how lasers work, laser design, construction, that sort of thing. Didn't love it, but it was between that and fluid mechanics. I didn't really want to do fluid mechanics because it seemed like a lot of differential equations and vector calculus that I couldn't be bothered with. And then we did a course in subatomic physics. So it was a mixture of, there was nuclear physics, there was particle physics, and there was a little bit of scattering theory from quantum mechanics sort of thrown in there, because obviously you need to know what a cross-section is and form factors to make sense of how we know things about particle physics and nuclear physics. It was not a particularly rigorous course, and it had loads of content, but it was entertaining, and maybe one day I'll end up as a particle physicist and I'll be talking about how life-changing it was. Then we did general relativity. It was sort of a first course in general relativity. We covered Einstein's equations, sort of tensors and how they work, but they weren't allowed to use the word manifold because it was a physics course, not a maths course. So they sort of brushed some of the maths under the rug. But talking about tensors, Einstein's equations, black holes, gravity in self-gravitating systems, so how a neutron star forms and its sort of equation of motion. We did a bit on gravitational radiation and some cosmology. And then a course on condensed matter physics, which was all over the place. There were sort of 10 different topics they taught us in 24 lectures, and it was sort of, here's some magnetism, here's some heat capacity stuff, here's what a phonon is, here's how diffraction off of lattices works, here's, I think I already said magnetism, but just sort of loads of different things sort of thrown at us in some detail, but it was very content heavy. Didn't love it. And then also I did some more relativistic quantum mechanics, sort of in preparation for this year. And then on the maths side of things, I followed through the Oxford course on commutative algebra. So that's sort of rings and modules 2, talking about sort of polynomial rings basically, and stuff like Hilbert's basis theorem, the Null-Stellenstats, Noetherian rings, some other stuff, dimension of rings, that sort of thing. And the reason I went through that is because, rather foolishly, I chose to do a course on scheme theory, which was taken from the 4th year of the maths course, because I thought, it's one course, it can't be that hard. It was that hard. Schemes are a sort of abstraction of algebraic geometry, and it was very abstract. It was more abstract than anything I'd sort of looked at before, and I did not do well. One day I will go back and I will relearn schemes properly and better. Not right now because I'm too busy doing other stuff, but one day, and then I'll put up a lecture course on schemes and it'll be incredible and everyone will know what a scheme is. But right now, schemes are horrible. Um, okay, and so then after my third year, I transferred to, still in Oxford, the MMath Phys, which is a master's year in mathematical and theoretical physics. Um, so this is something that I'd wanted to do for the whole time I was at Oxford. I wanted to transfer to this course. Even before then, when I first heard about it when I was sort of 16 or 17, I thought that's incredible. That's what I want to do. Which I think it's crazy that it was still what I wanted to do 4 or 5 years later. But it was. So Oxford years are split into 3 terms. I'm currently at the start of the second term right now. So I've done a lot this year already, so I've broken it up by term. So last term, this is sort of over 8 weeks, we had 16 lectures for most of these. So I did a first course in quantum field theory, sort of going through where does field theory come from, quantizing different classical field theories, building up where Feynman diagrams come from, a little bit on the path integral formalism of quantum field theory. Then General Relativity 1 was basically a do-over of our General Relativity course last year, but this time the lecturer was allowed to talk about differential geometry. So of the 16 lectures, I think 9 or maybe 10 even were just on differential geometry, sort of really building up to that rigorously, and then the rest was sort of a bit of special relativity to recap for maybe the people that hadn't done that before, because we've sort of merged with the maths course, and then Einstein's equations and some black hole stuff. Then I did a course in algebraic geometry, which is basically the study of the shapes of the zero sets of polynomials. It was pretty abstract. I think I will probably make videos on that where it's just going to be me going back through what we learned and trying to explain it to myself. That's something I do to revise sometimes, is I'll just film myself giving a mini lecture on something, and then if it's any good, I'll upload it here, and then everyone else can decide if it was actually any good. Then I did a course in algebraic topology, which is sort of the use of algebraic structures to study topological structures. So assigning a set of groups to a topological space that tell you sort of how many holes it has in different dimensions, basically. Category theory, which is like maths behind maths. It's a very abstract way of talking about sort of, normally in maths we have structures and arrows between them, so our structures might be, we're looking at vector spaces in linear algebra, and we've got linear maps, which are maps between them, and then looking at that and seeing, well, what things from how vector spaces work are because of vector spaces, and what things are like just a general thing because that's how maths works. So stuff like the direct sum of a vector space is not special to vector spaces. You can take the direct sum of many things, and it turns out to be this thing called a coproduct, which, you know, you can take the coproduct of groups of topological spaces, of many different mathematical structures. And then finally a course on groups and representations. So this was taught to physicists mainly, I think it was aimed at. So technically you didn't need to know what a group was going into it. There was a good 30 minutes at the start of the 24 hours of lectures where he established what a group was, and then we got into sort of the representation theory of finite groups, and then representation of Lie groups. There was some differential geometry building up to what a Lie group is and how you get the Lie algebra of a Lie group. So sort of really formally saying what it means to look at the tangent space to the Lie group, building the commutator, then the representation theory of the Lie algebra, which basically tells you how physics comes together. Because when you have, say, a relativistic quantum field, you have this group of symmetries, the Lorentz group of things that you can do, so you can boost and rotate and things, and then the field has to transform under a representation because the field transforms as the group transforms. But you can also look at the Lie algebra instead, because that's more easy to classify, basically. And then looking for sort of what things, talking about what won't transform under the group, because then that's something that's a good object for your quantum field theory. Then I also sort of followed along a bit, but I didn't have time to do everything I wanted to do last term. So I did a course on topological quantum theory, which was really interesting. It was by Steve Simon. He's got a book coming out soon on it. And sort of things in condensed matter physics where the physics ends up depending only on sort of topological invariance. So you get sort of amplitudes of scattering. Maybe scattering is not the right word, but transition amplitudes of quantum systems which depend only on the topology of the paths taken, sort of thing. It's not a great explanation, but then topological effects in weird particles that arise in condensed matter, sort of pseudoparticles, where, you know, crossing a particle like this and like this introduces some weird stuff. So you don't have a boson, you don't have a fermion, you have something else. It's called an anion or ennion. Then there was a course on advanced quantum theory, which was sort of starting with quantum mechanics and then looking at the path integral formalism, quantum mechanics of many bodies, some sort of interplay between quantum mechanics and statistical mechanics. It's taught as part of the Just Physics Masters as well. It's sort of what they do before they do quantum field theory. And then also some differential geometry last term. Because obviously it's very useful to everything I do in physics, because everything's a manifold. Even the Lie groups are manifolds. Everything's a manifold. Then this term, so sort of started Monday, and for the next 8 weeks I'm doing advanced quantum field theory. It's taking where we left off last time, which was we looked at sort of non-physical theories, some phi to the 4 theory mainly for scalar particles, a bit of fermionic stuff, and now we're sort of building onto that and sort of talking about, okay, now we want a proper sophisticated interacting field theory. So we're going to look at quantum electrodynamics, we're going to look at the electroweak theory, we're going to look at QCD and sort of build towards the standard model. Then string theory 1, which is really exciting. It's my first ever course in string theory. I have no idea where we're going with it and what we're going to get to. But I start lecture 2 tomorrow with the mechanics of a classical string at 9 a.m. Then I'm taking a course in supersymmetry and supergravity, a course in astroparticle physics, a course in cosmology, so the history and future of the universe, non-equilibrium statistical mechanics. I had my first lecture for that today. It was really interesting. It felt like actually doing physics again, because everything I did last term was very much more thinking about doing physics instead of actually doing physics, whereas this term we're actually doing calculations, and so we were just going through something about Brownian motion, but it felt like I was actually doing physics, which was nice. And then geometric group theory, that one's a maybe. I might do it. I might decide that it's not worth the amount of time it's going to take me because I don't need the extra credits. We'll see, but it's sort of talking about basically instead of using groups to classify topological spaces, using geometry to look at groups, presentations of groups, free groups, that sort of thing. I'll explain more once I've looked more. Then there's loads of courses I wanted to do this term, but physically it would be far too many hours in lectures, um, and far too many hours spent in exams at the end of the year, which I don't want. So sort of things I'm following informally. There's a course on low dimensional topology and knot theory, which is pretty good, pretty interesting looking. Riemannian geometry, so introducing metrics into differential geometry, which obviously as a physicist is very important. Non-commutative rings, it's not particularly applicable to physics, the sort of thing we do. Obviously, matrices are a non-commuting ring, but we don't really care about the ring structure of matrices as physicists. We care much more about their Lie algebra structure and commutators, really, which is not covered by this. This is a very pure maths course. And then there's also a second general relativity course. So they're going to be looking at some more cosmology, some more advanced black hole stuff. So I think Kerr black holes, maybe charged black holes, gravitational radiation. So something that I do find interesting, but it's just too many hours of exams if I take that too. And then I've got one more term left. I haven't officially decided what I'm doing next term. It might be that after this term I've had enough and I decide that I'm not going to do anything next term. I'm just going to revise for my exams. But otherwise, I am currently in the process, of writing a dissertation on deformation quantization. So going from classical mechanics, which is described by a Poisson manifold, and turning that into a Banach algebra, which are the operators of quantum mechanics. So really it's not the Poisson manifold that I care about, it's the Poisson algebra of observables on the Poisson manifold, and then the observables on quantum mechanics instead of the Hilbert space itself, because the Hilbert space is just a representation of the Banach space. So if I do go through with writing that, I'll be submitting that next term. Then we've got a course coming up on conformal field theory. We have a second string theory course which looks pretty interesting. Renormalization group, which is pretty useful for condensed matter more than anything. I don't think it's really aimed at particle theory, which is what I've been doing more of recently, but I think I'll give it a go because I do like a bit of condensed matter here and there. And then there's a couple of courses called Beyond the Standard Model, so talking about basically they're like frontiers of physics, what we think might be just beyond the standard model, and sort of the consequences of that. So some dark matter stuff, maybe some axion stuff. Again, I haven't looked in detail yet because it doesn't start until May, but it's something else that I'm thinking I might take next term. So that's everything I've done so far. What I'm doing after that, I haven't decided yet. I'm gonna take some time out. I'm not going to be going straight into a PhD. That's something I do know. I'll be focusing on my YouTube career instead, I guess. So that's what I've been up to since last time I made a YouTube video, and hopefully I'll be back in about a week with another vlog. And so I guess I'll see you next time.